website. May or may not have what you need, but if it does, it's very helpful. Ever wonder what the biggest roller might be? Okay, I have so this DVD is in our office, in our little hidden cabinet. And I'm not going to show you the whole thing, or we'd be here all day. But I'm going to show you portions of it. Because it has a lot of really good information. And some of the techniques you'll be able to use on your lab. So I'm going to kind of be skipping around in it. But if you need to stand up to stay awake, please feel free to do so. Really good information in here. Oh, you need to see it. That might be helpful. Good old FBI. This is Ron and Ron.
Hi, I'm Ron Fournier.
And I'm Ron Covell.
Ron and I have been friends for years, and we decided to do a video together on hammer forming. A lot of people don't even know what a hammer form is.
I learned about hammer forming from Ron Fournier's books years ago, and until I'd read the books, I wasn't even aware that the process existed. A form block, or hammer form, is a shaped block made of wood, metal, or some other dense material, which is used as an aid for shaping sheet metal. The block is shaped to a particular contour, then a piece of metal is clamped against it, and worked with a hammer in such a way that the metal takes on the shape of the form. It's an ideal process to use in situations where accuracy and repeatability are required. It's good for one-off and short production run parts.
These are the ones I'm going to demonstrate. The first one is a 6-inch diameter tank top. It's made out of micarta. It has a particle board clamping block. The next one is a small wing section. The darker section we're going to use to form over. The light section is the clamping block. This one is a form for a aqueduct. An aqueduct is a kind of air scoop that will take air in without pulling air out of the main air stream. They're very popular on dragsters. And next we're going to do some demonstrations. Okay, right now I'm going to show you some simple small hammer forms used to make small metal parts. I'm also going to demonstrate how to make a small round tank top. First of all these brackets are quite small. They're the kind of bracket you could form up easily and quickly and put them on any kind of a race car, custom car. They're pretty much general shape brackets, and what I'm doing right now, I've got this part formed on here so tight that I need to take it off by prying it off. These are 16 gauge steel, mild steel parts. The typical two-piece hammer form that's both bolted together and pinched in a vise. This size is great for working in vices. There's another part here that was made earlier, a little bit of layout die on the back side. Okay, here's an even smaller one. It's obviously a little bracket, but it's really very fancy and very good looking because it has a beautiful rolled over surface here and about a 1/4 inch deep angle that makes it tremendously stiff. A 1/4 inch diameter bolt would go through the middle. And then this one is quite hefty. The reason that this form is so deep is because I need the full depth at the bottom across here, so I have a good strong back brace on it. Then at the top it rolls off much smaller, about 1/4 inch. And you notice the bolt size here is 3/8 of an inch. That's because the real part needed a 3/8 bolt to go through it. And again, more, as you can see the big vise marks on here, it's because not only was it bolted together when I formed it, but it was pinched really tight in the vise. Let's look at this next hammer form right over here. This is my 6-inch diameter tank top form. Now let's take a look at my disc here. How did I come up with this diameter disc for this form? Well, first of all, I determined how much depth I wanted. How deep did I want this part? I wanted it 1/4 of an inch, and I marked it very clearly on my form. It's right at the top of that tape. So what I'll do is I'll turn a little bit sideways here so you can see better. I take a piece of cardboard and I'll lay it on top, and I'll bend the cardboard right over until I hit the 1/4 inch mark. Right there. Now I'm going to take my ballpoint pen and I'm going to mark the center of the form. Now all I need to do is measure this length and double it. Okay, I've got 3 1/16. So I'm going to go 6 1/8 on my diameter. Now instead of using a bolt to put through here, I'm just using a little pin, a little hollow pin. The reason that I'm doing this is I don't want the bolt to be in my way. I only have to use 1 clamp on this. More clamps would be simply get in my way. There's my alignment. I can put my clamp on right now. So I'm going to start out using a wooden corking tool just to get things started. I can rotate the clamp right out of the way. All right. That looks pretty good. I could have made it deeper. If I did, it would have required some more shrinking. Turn it upside down. A little tapping action. Tightens it right up. You're at a real advantage doing this because you can see if there's any gaps right in here. You can go right after them. There we go. We got a nice looking part. It's nice and smooth and even. This is a great project. It doesn't take a lot of work or a lot of fancy equipment. This would be a great project for you guys to try out at home.
For the next demonstration, we're going to make a replacement grill bar for 39 using heat as an aid to the hammer forming process. Incidentally, I've used this same form to create parts from 1/8 thick steel. Again, you'd have to use heat, you'd have to heat the steel to red heat, but it can form a nice radiused edge and quite a wide flange, even on a steel part.
Okay, for my next demonstration, I'm going to form a bowl. The bowl diameter is 7 1/2 inches by 1 1/2 inches deep. I've got a nice freshly annealed piece of aluminum. It's 50 thousandths thick. I've also got a locator ring on the bottom form. This form has been cut in a mill to get a really constant, beautiful shape inside here, and we're going to form the metal down to that. I'll put this right in position. My top ring has got some locator pin points, which I'll use. Now I'm ready to clamp it. These clamps are very important. The tightness is extremely important for the shaping process to take place. Nothing can slip. It all has to stay in position. Now I've very carefully chosen a hammer that has the correct curvature. This curve matches the shape that I'm going to try to form. If I were to use, let's say, this end of it, which is much sharper, I'd put a bunch of dents in here as I'm forming it, and I would just have to remove the dents later on. So I'm going to go with this side. It matches perfectly. I'm going to start in the middle and spiral outward, and I'll repeat that process until I've hit the bottom. I'll hit much harder in the middle, and I'll lighten up on the blow as I go to the outside. Notice the difference in the sound is when I'm starting to hit now, I'm hearing a real solid noise rather than a hollow. That means I'm really starting to come into contact with that lower form. My eyes and my hands will pretty much be able to tell me where I'm at, and if I need to do any more shaping or any more stretching. If I feel a bump, a high spot, I'll go after it. Now it's starting to look and feel pretty good, and I'm going to go ahead after a minute here and release it. Okay. Okay, it came out quite nice. There's a couple of irregularities here and there. I could go back in here and pick them back out, or I could go to an English wheel, find an anvil that fits very, very close to the bottom shape of the wheel, and smooth it up. I'm going to do another one of these, but I'm going to do it a completely different way. My other disc, I'll put it in position, clamp it down. This time I'm going to use a little bit of air power. This tool is a handheld planishing hammer made by Eckold. It's got a nice controllable air nozzle right here, which I can control how hard and how often it hits. Now it's a good idea to put just a little bit of oil on your work, a little bit of WD-40. It just makes the hammer glide around much easier. I'm still going to start at the center and then spiral outward. Yeah, from all the way to the outside, I'm going to start again at the inside. now I'm starting to hear a little different tone of when I'm hammering, and what's happening is I'm starting to touch that bottom form. I know I'm getting very close to where I want to be. After I get there, I'm going to change the pressure on my hammer here so that I can do a little bit finer planishing. But right now I'm going to stay heavy and get it down to the bottom. Okay, now I'm going to lighten up a little bit. I'll do the same thing. I'll put my hand in there and fingertips and feel what I've got. Feels pretty good. I'm going to release it and have a look at it. Right out of the form. It's much nicer than the hammer job. Of course, the reason is I was only able to hit it maybe 1,000 times with a hammer, and I've already hit it 2,000 times with the air hammer. The more hits, the smoother the surface.
Now we're going to look at a female hammer form used to make a very complicated part. This is actually a flying wire cover. It goes on a biplane. It covers the part where the cable from the wing goes into the fuselage. And I had a good original part I had to copy. Most hammer forms are what I call male hammer forms, so the top surface is flat, the edge may be rounded, but the reason most of them are flat is because the material we make hammer forms from usually comes in flat sheets. Metal comes in flat sheets, plywood, MDF all come in flat sheets. But every now and then you'll have to shape a part into a cavity. And it's difficult to carve a cavity with a high degree of accuracy. So I made this hammer form in a different way. I started by gluing together several pieces of MDF, all cut to the same size. After they were glued together, I cut a hole through the stack, and this hole is just slightly larger than the perimeter of the part to be made. Then I took the good original part, I covered the openings in it with bits of masking tape to seal it. Then the part was put in the form, the assembly was turned upside down, and I filled it from the back side with plastic auto body filler, Bondo. Once the Bondo had hardened, I released the part. By the way, it is important to use a release agent, otherwise you'll stick the original part to the plastic filler, and wax is a good release agent. Then when the part is popped out, you have a very, very accurately sized cavity that matches the original part with a high degree of precision. So this is the form we use to make the part. And of course the next step would be to anneal a piece of metal, cut it to size, lay it over the form. This is the clamping block used for this part. And you might notice that the edge of this form is cut at a 45-degree angle. There's a very good reason for this. The 45-degree angle allows us to get the mallet very close to the edge of the form. If this had a square shoulder, I could not get the hammer right up to the edge of the form. So that's a very important detail. And then alignment pins are used to hold all three pieces in a proper alignment. And this is what the part looks like just as it's rough formed. One more thing to pay attention to, you'll notice I have a very wide flange around the part with a shallow slope, but the flange around the nose of it is much narrower. And this is actually an advantage. As you're shaping metal into a deep cavity, you actually are able to pull metal into the cavity, and if the metal can flow, the metal does not thin nearly so much where you're hammering on it. If we'd had a very wide flange on the part at this point, no metal flow could happen, and we could get the part formed with no problem, but I'm sure it would be thinner in this spot because we couldn't pull any metal in from the flange. And I believe you can see how the flange is wrinkled as it was pulled as the metal was pulled through the flange area into the cavity. So again, this is a relatively simple hammer form, not hard to make at all since we're making the cavity by the casting process, and it makes an absolutely gorgeous part. Again, it looks die stamped, it looks store-bought, it's just as nice as it could be.
I've got two different hammer forms that I can form wing ribs on. I've got a wooden one and an aluminum one. The smaller one here, I've used many, many times to form small aluminum ribs. Now, this is another one. It is wood, it's much bigger, and I've never made this one yet. We'll make it today in a demonstration. The darker part is the part I'm going to form over. The light part is my clamping block. I have the same kind of a situation here. I've got a bolt at each end, which will provide both a pin locating and it will provide pinching pressure, while the main section will be held in a vise while I form it. Now, what I'm going to do, because I haven't made this yet, I need to make a pattern. Let me run you through how we'll make a pattern for it. When you form a wing rib, the side shape is already predetermined on how big it's going to be because it's going over the shape. But what you have to determine is how deep you want this flange. Now, it only has to be deep enough for a rivet. I'm going to put in 5/8 of an inch of a flange all the way around, except at the front leading edge, because you know what? You don't need a big flange at the leading edge. You don't put rivets on the leading edge. But you do need enough. In this case, I'm going to put a 1/4 inch on so that the part retains its stiffness and it has a good wrapping surface. Okay, we're going to start out by putting it right down on a piece of cardboard. I'm going to clamp it down so it doesn't shift. I'm going to use a 1/4 inch transfer punch to mark my two locators, bolt holes right into the cardboard. I'm going to make an outline of the wing shape. Ballpoint pen, nice and crisp and dark. Now, to mark the 5/8 of an inch of material that I have to add on to this blank pattern, I'll just simply use a pair of pencil dividers. I'll set them here at 5/8 of an inch and swing across the part. Now at the front, where I want less material, I'll just draw in a smaller flange and blend it into the upper and lower section. Now from this point, I would just take a pair of scissors and cut it out, and I would end up with a pattern that looked just like this, with the two bolt points on it, a nice black line which will let me reshuffle where this goes, and it's got the added material. Clamp it up tight so it can't move. I'll transfer punch right into the aluminum. Now I'm going to take a kind of a pointed tip black magic marker and mark my outside cut line. I could use a scriber here too. It really doesn't matter. It ends up getting cut off with a bandsaw, and then you'll need to clean it up in a disc sander and also a file. It's got to look real good before you form it. And I'll end up with a piece that looks just like this. Let's go ahead. We're going to put this all together now. We're going to bolt it together, and then we're going to move over to the vise and start hammer forming it. Okay, now's the time. It's really nice and secure, and I can tighten it. What's nice about doing this is that obviously I could use a clamp here, but if I do, the clamp gets in my way. So this is a good deal. Now I might mention right now that this piece has been annealed. Now I'm going to start my shaping with a little wooden corking tool. I'm going to keep it down tight against the form so that I get a nice crisp fit right along the edge right here. I'll work it just past the end here. I'll go a little bit past the tip. Just concentrate on the high spots. You can work them out. Okay, another great tool that we can use here is a leather face slapper. It's got plenty of weight to it, and it's really what I call a harmless tool. You really have to do something crazy to hit this metal and hurt it with this tool, because it's got this nice leather face on it. I guess what I'm really trying to say is that you wouldn't want to hit this with a steel hammer. You're just going to end up putting marks in your work. Hit it with this. You'll move the metal. It'll look smooth. Okay. Now what I'm going to do is just simply turn it over and repeat what I just did. Okay. What you need to realize is a lot of guys, when they build a wing, not only do they rivet the skin to the ribs for strength, but they put a bonding epoxy on here. This makes the wing much, much stronger. So the irregularities that I have in here wouldn't really make a great bonding surface. So what I'm going to do is I'm going to take and clean it up really good with a file, and then I'm going to use some sandpaper on it. I'm using a little bit of real, dry soap, a great lubricant, and I'm going to draw file it and quickly find the high spots and get them off. See, the smoother this surface is, the better the bond will be when you connect the skin. Okay, now that was a fairly coarse file. I'll do one more filing with a smooth cut file, and then I'm going to hit it with a sanding block. My goal here simply is to get this surface as nice as I can so the bond will be excellent. And there we go. There's a beautiful surface. Hard to believe it was pounded into place. Okay, my next step to complete this part would, of course, be to repeat the cleaning and smoothing up surface on the other side, and then simply release it from the form. And I've got a real nice medium to large size wing rib.
How many of you think that what he just did to that, to form that wing rib, you could do to form a certified aircraft structural wing rib? Very good. However, the techniques he used, super Jake? I'm baffled. I don't know. Are you baffled? For my
Engine, the little wings. Yeah, the little fingerboard.
You jumped way ahead of me. Alright, so I hope you're not baffled. This is this is engine baffling. Why? And here I've got a picture of some baffling on an engine, all this red stuff. What's the purpose of baffling? Airflow for cooling. And I have a whole class on cooling, so I'm not going to go into it now, other than it is directing airflow to go over these cylinder fins and down and out. So the cylinders and the engine are properly cooled. So do you think it is a structural component? Correct, it is not. However, is it important? And how close you have it to the fins, do you think that is important? Very much. So, our lab project for you is going to be on, no, it's not exactly like this, but it's going to be on O540, light coming engine, the front left baffle, so this area right here, right there in case you don't see the little flamity. And this is the old baffle. Anna or I can show you the engine. So you can take this old one and see how it fits in there. These pieces go slide under the cylinder fins. There's some other components you need to make sure you're clear of. Unfortunately, we're going to simulate this is all cracked and you need to replace it. So, what you're going to do, I opened up the lab in Moodle. It is the last lab. Hooray for you. Lab 8, cold forming. And if you go into that lab, I hope, it works on mine, so hopefully it works on yours. You see this little icon. You click on the words below it. It'll bring up PowerPoint. Anyway, hopefully it brings it up in some format that you can view it. And it steps you through how to make this part. So, if you want to really carefully measure every single little thing and do a lot of math, have fun, it's great, thrilled and excited, but you do not have to. Probably the easiest method is what it describes right here. Take some paper, lay it right over the old part, making sure you're duplicating any holes, any little protrusions, curves, and wrap all the entire one side. Combination of paper, painter's tape, whatever kind of works for you. Get all areas covered, and then make sure you get the outline carefully, very carefully. Unwrap it, lay that out, and then you can copy it onto any bigger pieces of paper. See me, I can show you where that is. Nice clean sheet of paper, transfer your layout. And if you want to use a copier or scanner, however, to make nice clean lines of your layout, use that as a template right onto your piece of sheet metal. Cut that out, making sure you're drilling relief holes at any areas that are cut. So relief holes up in here. There's a drill relief holes, file deeper edges, and make sure you're making bends and bend radiuses the same as the old part. Again, don't have to be exactly measuring, just get drill bit, see what matches that, and then make your bend radiuses the same. You'll be using the same gauge thickness as the original options in here. You can use the slip roller, or you can use, I think what the next one has, we had this bending, cold forming tool out in the sheet metal shop, so you can use that as well. Use your imagination, use your creativity to experiment, do what works. And so you need to find same thickness of material. Also, very critical, this piece right in here, so that it starts right there, bends, comes over here, and it's curved. That's probably going to give you the most grief. Make sure you are using soft aluminum for that piece. Otherwise, you're going to get extremely frustrated. And consider annealing, because this is not structural. So if you go to AC 4313 and anneal this piece before you try to form it, it may help you. You may also want to take a piece of wood and make a form to form that over. Some options to throw out there. I need to hand out your actual paper lab. That has some directions on it, instead of me just talking to your faces.
Aren't there part numbers for these pieces?
Okay.
Here's how I would order it.
So, if you take your lab sheet and the first, actually, page 2, it says instructions, and then it says group number and group numbers. I'm gonna let you, I want you to do it in groups of 2. So group number, I'm not assigning you, you can choose your partners. So everybody needs one partner, groups of 2, if that makes sense. Because there's, hopefully, everybody will be back. So then it gives you a scenario. You're a mechanic working in a small FBO shop and baffle's cracked. Then it gives you the guidelines. So your new baffle must fit exactly as the original fit and have the same attach points. So pay attention. All these little holes are actually very important. Same material types and thickness. You can make modifications or improvements to the baffle that you deem necessary. However, dramatic deviations from the original design are not allowed. If in doubt, ask me. So some things that might be helpful, actually. So on this is a example replica. So on the original, this piece here is a separate piece. On this example, he just bent it as part of that whole piece. So whatever is easier. There's another one. Oh yeah, this piece here is separate. That'll probably be easier. This extra little bit here, you don't have to worry about making that part. That's just extra that you could take off of here and put onto your part. So you don't have to make that part. But this angle, that angle, these here, I want to see all of those as well as the properly drilled holes. Use appropriate cold forming techniques. Aviation grade fasteners must be used in construction. Here's a helpful tidbit if you want to jot this down. So in this area here, a really good idea that will help save you grief is to use soft aluminum rivets. So you don't even have to use a rivet gun, you can use a rivet squeezer possibly. An idea is good. Then you'll be sealing it with primer, install the part on the engine. So what I want you to do, I want you to, once you get your, I have an example template also. So take this old part, lay your paper over it, get a good template, kind of see how this fits, what parts are important. I like to see your template before you start cutting out aluminum. And if you feel like you're destroying your aluminum, see me before, because takes a good bit of material. So see me before you start over again if you think you have to start over again. And then I want to see your piece before you install it on the engine, or as you install it, like before you prime it. There we go, in case you have to change anything. And then you prime it, grab me, throw it, because it's just a couple little attach points. Because I want, as all the groups are working, I don't want one group to be blocked by somebody that has it installed and they're like, oh wait, I want her to check this. So get me, I'll come watch you install it on your engine, say yay or nay, take it off to the next group. And then there is a logbook entry with the information and scenario. Yes. Very much. So they haven't done this specific baffle, but they've done baffles over at LLC because these are actually crazy expensive to buy. So especially small shops will want you to just make your own, especially if you have good stock aluminum. This one's more challenging, but if you can make this one, you'll be good making baffle. You'll be a baffle expert. And yeah, it's use your creativity, imagination. Last year, they looked at this and like, oh my word. And then afterwards, they're like, actually that's kind of fun because we got to be creative with it, with how to make it. So don't be too worried. Yes.
How many of the original parts do we have to work with?
Just one. So that's why I take it, layer paper over it, get a good outline of it. And then I would like you to keep it with the engine so that it doesn't go straying. So let it live with the engine, go over there, see how it fits, you'll get a good idea. I'll have this like at the table area where I kind of set my stuff. So you have this at the engine to look at on the engine, and then as you're working on your part, you can come to this. So this is a good reference as well. Any other questions? So today, what I would like, actually, how many of you are ready with your flush patch that you would be ready to do sealant today? 1, 2, 3 and a half. And a couple halves. Okay. What I want, let me actually, so, Leo, how many up here? And anybody else in S.C. Parker? Maybe Isaac, maybe that. Elijah, were you a maybe? Anybody on this side?
Maybe.
Okay. 1, 2, 3, 4, 5, 6, 7, 8. That's a good group. Anybody else that I missed? Anybody else? Okay. So, the ones of you that were maybes, let me know when you're ready. We might not get sealed today, but tomorrow, I would like everybody for today to focus on the flush patch, getting that all ready to go, because that is kind of, I want that done so that everybody can be sealing close to the same time so I can have the equipment out. Once you're done flush patching, then I would like the focus to be on this, since this is in groups, and pair up and get this done. The other stuff, like your riveting project, special fasteners, and structural rib repair, you can kind of put that on hold till you get these things finished. And I know a lot of stuff was thrown at you this past week, so we're going to have lab time pretty much the rest of this week and also next Monday. But please don't freak out. Like, if you feel you'll need time after the class is over, just talk to me and we're not going to kick you out or anything. So you'll have time. Don't stress, because then if you stress, I feel very sad. Because I stressed when I took this class as a student. So you'll have time to get it done. Any questions? Okay. To the lab, and as you finish up, get your flush patch ready, see me, and hopefully we can get a group. Yeah, to do the stress skin repair first, and then the flush patch is after that. Don't stress out over stress skin. Okay. You just do one.
I said about these being fairly safe. I don't think that's entirely true. We've had people. What? That's what I was. I do not care. We've had people drill through the pants. I feel like you could do a lot more damage with this.
I feel like you're not going to be hurt. Either way. Go with Christina.
Yeah.
Carry this over for you.
But yeah, I'll trust you. If you lose it, then I'll take up a contract.
Wait, we have to.
You are good. Well done.
How strict are you on doing the patch?
What do you mean?
Specifically.
Oh, to get it done?
Yeah.
I'd really like if you could. What is holding you up?